last time we have not the lecture week 6. So in the week 5, we have discussed about the investing and casting procedure. This investing, if you see these three pictures, these are very important. The first picture, if you see this, the man is having this. This is the machine. You can call mechanical mixture of the investment material. Here, this if you see here, this man is having the crucible former in which he is pouring the investment material. And if you see here in this third picture, this glowing part is the metal which is going to be melting here. Okay. Already we discussed so many things before also, like why we are using this topic, what are the steps of fabrication. I have already discussed with you, and why we are doing this wax-up procedure, why we are using this, the types of alloys, why we are using these alloys, the classifications, and how we select the alloy, then investment material, what are the requirements, how can we compensate this shrinkage and expansions there, and all these are the, then we have the investment, we have gypsum, then we have phosphate bonded, and I told you that gypsum bonded investment we are using for the type 1, 2, 3 gold alloys. And we are continuing with these gold alloys. Now the important part is that I told you what is the investment material and what is the classification. This is all the theoretical, but now we will check this how we will make the sprue former. What is the attachments there, and how we can make the attach, how can we attach, and what are the principles of its attachments. Okay, there are three components. First is the sprue former, another is crucible former, and another thing is casting ring. Now, if you see this, this looks like a square, but it is a round form. It is a cylinder form. And if you see here, the first ring, if you say this is the casting ring, this is the ring, casting ring. So definitely it is in the metal form. The first layer you can see it is the casting ring. And if you see this is the crucible former, which comes like the some lid which has to close at one end. So this is called as a crucible former. And in this crucible former, we have to attach with the help of the sprue this wax pattern. And when we are doing this casting, we have to put one of the ring liner here, which is shorter from above and lower. And then we will put in between here the all the investment things. I got it. Um, what is the size? If you see here, thicker than the size of the, we are calling about this size of this sprue former. This is a small sprue former. It should be thicker than the thickest portion of the wax pattern. If you see, this is the thickest portion of the wax pattern, and we are attaching it at this place. And usually it is 2.6 millimeter for molar and metal ceramic restoration, and 2 millimeter, that is 12 gauge, for the premolar and the partial coverage. And if you are using the large sprue format, this is the sprue format if you are using, then there will be the distortion. And if you are using too long or too thin, then there will be the problem, and that is called the shrink spot porosity. I will tell you later on what are these things. Now the area of attachment, if you see how they are attached here, you see these are all the sprue former attachments. Okay, to the portion of the pattern with the greatest bulk, I told you it has to be at the greatest bulk, and it should be away from the margins. You see, this is the away from the margins. Away, this is your margins, and this should be away from the margins. So why we are making it away from the margin? Why we are making it from the thickest portion, so that the flow of alloy, because these are the areas which is formed in the investment, and we will put the alloy and it will come from these areas and it will fill to other areas. So we will start from these bulky areas. Flow of alloy from thick to surrounding thin areas will reduce the turbulence, and orientation is 45-degree angulation, and if you are doing it 90-degree angulation, then there will be the hot spot, or you can call it a suck back porosity. Porosity means you can find some small dots in your castings. In the molar, have to make it on the non-functional cusp areas. You see here, it is not in the center; it is slightly on the non-functional cusp area. And if you see the incisor, then it should be in the middle of the incisal areas. You see here how they have changed in the different shapes according to different areas. Then what is the length? The highest point on the wax pattern, the highest point of this is a wax pattern, highest point, it should be 6 millimeter from the end of the ring. This is your ring, and this area, it should be 6 millimeter from this area. And because if it is too close, if it will come here, it will blast when you will do the casting. And if it is too far away, it is very low, then the gases may not able to escape and will cause a gaseous process. The sprue itself, if you say this is sprue, it should be not longer than the 6 millimeter. Method of spraying, how can you spray it? There is direct method, there is indirect method, there is a single wax pattern. You can make it direct, you can make it direct like zigzag. If it is two, you can make the two one also. You see here double pattern directly, make one here, or indirect, make join two together and then down, or you can make it this one also indirect here. If it is multiple, 2, 3 you can make it directly, or you can make indirectly like this. Directly means direct connection between the sprue former and the pattern area. It is common to use indirect sprueing for multiples, single units and FPDs. You can use, maybe it is the FPD, maybe you can use different single crowns as well, but they have to be joined together with the sprue. Now we will come to the investment procedure. So what we will do, this is, if you see here, this is your casting ring. In the casting ring, this is your black color metal part. Now in this, you have put this ring liner. This is called as a resilient ring. Resilient ring liner. It is pressed. It has to be pressed inside this ring. And why TBRV? Because it is a buffer for investment. Because I told you before also, when investment set, it will be enlarged. So first it will compensate for enlargement, and another easy removal of investment from the ring. Because when you remove this ring, maybe investment will get stuck to the ring. So when we will remove this paper, it will come out. Materials, you can use asbestos, you can use ceramic paper, you can use cellulose material, and you have to adapt the liner that is 3 millimeters short of both the ends. And if you see here, this is ring liner is here and here. So if you see, it is short from 3 mm from here and 3 from here. First, ring liner, take the ring, put the ring liner there. Okay. The wax, you have attached the this is a sprue former. This you can call it a cover or lid of the crucible former or whatever you can call it. You have to attach your sprue here, and now you can mix the investment material. Either you can mix, first you will clean this wax pattern with the commercial wax pattern cleaner there, or with the detergent even, and you can mix it this investment, and you can mix it with the hand mixer, or you can use the mechanical with the hand also, and this is your mechanical mixer. Or if you are putting this investment, either you can use with the brush, you can take this investment with the help of the brush, put it around it, and you can fill it like this and vibrate it. So then you can, that is called a vacuum technique, or you can fill it with here also. So then it can be filled. You can see here the vacuum investing. You have the same material. This is the same instrument which is used for mixing the instrument, can also be used to fill this under the vacuum. You can see here, this is the mixing in this part. You can mix it with the help of the machine, and in this part you can see it can be removed, and you can attach here also to fill your casting ring also. Then once you have done the casting, you have fill it, you can wait for the set of the investment material. Once it is set, you can go for the wax burnout procedure. You can see here how can you burn out it. When you are giving the heat, there is a procedure lead to wax burnout, and also the thermal expansion. Now you have two techniques. You can make it high temperature technique, in which you will make this much of the temperature, 650 degrees centigrade, 1200 Fahrenheit, and the thermal expansion, it will give you the compensatory expansion for the investment expansion. And there is lower temperature technique also. What you will do, place the investment in 100 degree Fahrenheit water bath first, and then you will increase the temperature to 480 degrees centigrade. And there will be the hygroscopic expansion, and it is used for the compensation. If you are doing the gradual heating, it will allow you to steam escapement there. Same methods I am telling you. Once you have done the casting and you have done the burnout, this form will be appear. This is the casting of the molten. There is a space here. This is your wax pattern. This will be the space after the burnout procedure. How can you do the casting now? First, preparation, dye and cast system, then wax pattern, then you will make the sprue former, then you have to attach that with the ring liner, then you will put the investment material, then you will go for burnout procedure. When it is burnout, it is clean. Now is the time to put the alloy there. Now when you are putting the alloy, that method is called the casting technique, and they, because we are using the gypsum bonded, it is was used for type 2 and 3 gold alloys. So no more than 30 seconds should be allowed to elapse between the time the ring is removed from the oven and the molten alloy is centrifuged into the into the mold. You see this machine centrifuge, you have to give it the round turns so that it will move very in the centrifuge. And this is called centrifuge when it is moving very. You have seen these centrifuge machines, I think. An undue delay will cause heat loss and resultant mold contraction. How? If you see, this is the machine, this is the pin which from which it is attached, this is the bracket. Here we have to put the molten, we have to put the metal here, and the ring on which you have to make this alloy to go into this ring, it should be at the back here. Okay. And here, this is the centrifuge, this is the counterweight, and from here only you can centrifuge the machine, this one. And if you see why we are giving you the zones of flame, because when you are going to heat the alloy, you have to use this torch for the alloy. So there are zones of flame. There is innermost, which is called as a no heat area. First, you say first long zone here, or this one is the first long zone. Eventually, that is emanating directly from the nozzle, and in here, this area, there is air and gas. They are mixing here. Then there's another zone that is called a combustion zone, that where the gas and air are partially burned, and it is called as the combustion zone. Reducing zone is the hottest part of the flame. It constantly on it, this part. This, if you see, a reducing part should be constantly on the alloy during the melting. And this is oxidizing zone, outer zone. Combustion occur with the oxygen in the air, and it has a lower temperature. This is the hottest part, that is a reducing zone. Same is this, they are telling you here. Now you have to use the flux. Why we are using sprinkle when it is warm, you have to sprinkle some of the flux there, that is called borax, to avoid oxidation of metal during the melting and maintain the composition of the alloy. Now if you see here, this is the centrifugal machine. Now here in this crucible you put this alloy here. Once you have put the alloy, this is the torch on which you have to give the all the light there so that it will be melted once. And this is the ring. Once it is melted, you have to put this ring down on this portion, and you will round it, this machine, centrifugal machine, you make them, you will give it turns so that it will move nicely. And with this movement only, because this is very, what you can say, if you know the toy which have some key, when you move the key, it is, you are giving some turns. When you leave it, it will move very fastly, that toy with the this key. Same thing is that you have to give it turns so that it will, when you release the turns, it will keep moving. This is a centrifugal machine. This is the molten alloy here. After the casting is finished, what you will do, 5 minutes. 5 minutes after completion of casting, and the gold button lost its glow. Then you have to quench it. Quench it means quench in the cold water to best grain structure. If you, when it's just you have finished, when the machine stops and you just take the casting, put it in the cold water, that is called early quenching. It will give soft and decold oil. Or if you will delay it or you will allow it to cool, that is called bench cooling, it will give you the large grain structure. So 5 minutes after completion, you will put it in the cold water. So quenching helps in disintegration of the investment as well. And there's one term we can use only for the gold alloys, only for the gold alloys. Better to use instead of this water. Your pickling is better to use hot acid, not the boil, or sulfuric acid for cleaning of only gold alloys. A porcelain, once you have done this cleaning everything, porcelain casserole dish and plastic covered plates are used because a metal instrument, if it contact with the gold, it will give the electrodeposition of the things. This is you put it there. Now, once you have done your casting, now you can see for the errors, if there is anything, if you see there's the common things, it will come in your, so many times it will come in your e-assignments or in your, so this, what you call in final exams even. If you see this is the large nodule. Normally you see it is just continuous here, but this is a large nodule. Why? Because air is entrapped during investment. This is multiple random nodules. It is inadequate vacuum during the mixing. If you see only on this surface, underside only, then that's been prolonged vibration after the pouring. If you see here, this is called shrink spot porosity. Either your sprue attachment is very bulky or your sprue is very thin, or button, this is called a button where you have attached it, it is very small. This is your random porosity. It will due to the dirt in the wax pattern, loose particles of investment from sharp edges. When we always ask you, don't make the sharp edges because the loose water will come inside it. Then you have the called as the fins here. These are the just the dots and these are nodules. Now this is called a fin. Dropped ring, rapid heating of the wet or under this what is called under unhardened mold, liner flushed with the end of the ring, and excessive casting point. All this is in your book or in your PDF there. So just read this copy and casting defects there. Or you have, if you see here, this is short and rounded margins are there. That's mean not enough to or insufficient casting, it will not flow directly there. If it is short rounded margins also with the short this button sharp button, it will come pattern too far from the end of the ring. Or if the casting is shiny, there is incomplete burnout of the wax. And if it is your black rough casting, that means black, this is your breakdown of the investment from the excessive heat. Now this is done for your FPD or crown. Now if you are doing for the inlay and dowel pins, dowel means post and core. You can make it in the this dowel. You have the exercise in your this also, and if you have read your um, post and core part. One is a post which is prefabricated. Another we have to custom made. Custom made means we have to take the impression of the post you have prepared in the root canal with the help of some bristles like your hairbrush. You take out one of the bristle or some other file or something are there. You take the impression inside of the root canal so that it will invest and cast it for the dowel. That is your dowel. And the inlay, you already know about the inlay. So expansion of the investment is controlled by, you cannot make, if you are making inlay dowel, you cannot put this ring liner, and you have to increase the water powder ratio. And this is, and for the gypsum bonded, for the phosphate bonded investment, it is much stronger and withstand much higher temperature. They are used for investing and casting alloy with high melting temperature. For example, silver, palladium, gold, platinum, and nickel, chromium. Normally, we are not using silver, palladium, gold, but we are using the nickel, chromium for the FPD. So we are using the phosphate bonded investment, and the casting range is more, that is 2100 degree Fahrenheit. There we are using 1000 to 1200. Here we are using doubled it. Powder, we have the phosphate of magnesium ammonium, we have graphite that is called carbon, and we have large silica bulk, and we have special liquid which is the colloidal silica aqueous solution. For the investment procedure, we are not going in the direct in the whole procedure. There are just differences, small differences there. Low fusion gold alloys costing normally when you are using the gold alloys, it is this preformer we are using directly. But for the metal ceramic, we are using indirect. You see here, this is one thing, then it is make the direct indirect here. Because the alloy used fuse and solidify at high temperature, so it will flow from these areas. Okay, you can see here, this is the ring former, and you can see here ring liner, and you can see this is the investment here, and you can find these attachments here. What is the casting technique? Since heat is required more, so gas, oxygen, multi, or if a torch is used, one difference, alloy is melted until it turns to mirror like white and casting completed with the standard protocol. There it is more like golden color, and here it will like a mirror like. Other methods by which you can use this is induction casting. Machines can also be used for casting. No pickling is there, only air abrasion with 50 micron alumina for cleaning the investment material. Here we are doing the pickling there so that investment will be broke down, but here we are using only the air abrasion. Got it, girls? Any question regarding this, girls?